I'm Dan Mummy, and come on in. I'll show you what I'm doing. So over here we have what are called trap cultures for arbuscular mycorrhizae fungi. And these, I've started them using cheatgrass soil, and over here knapweed soil. I wanted to do this with a number of different types of soils. For example, root balls of native plants that are enriched for species that are associated with each of those. So we've got soil and sand mix. We plant a trap plant in each one, AMF or obligate biotrophs. So they require, cultivation of AMF requires that we grow them in a host species. So we're amplifying the AMF that are present here and then in each soil. And then the sand allows for us to isolate the spores relatively easily. We can then pick them out and use them to infect a new plant and then have a pure species. So this led to development of ways that we can actually pre-inoculate in the field, and we came up with this tube design. So we fill these up with pre-inoculants, add seeds, particularly, especially for shrubs, and this will add a little water, and then the entire growth, root growth through this section, they would be only exposed to what we want to expose them to in terms of AMF. So pre-inoculated in the field. Another potential advantage to these tubes is that this would force root growth potentially down below the abundant roots of the grass species, which tend to be more on the surface. So we can push them towards the niche that they would dominate anyway once they became established without the competition. And a potential third advantage to these is that this rigid plastic material may minimize large animal or small animal browsing, which is expected to be a huge problem, especially for our bitterbrush. And I've been constructing funnels on the top, to go on the top, to increase the area to capture rain. So that could potentially steal water from that would normally be falling on the surrounding area and funnel it right down into the shrub that we're planting. Also, these should act as little greenhouses. So planting them early in the may allow for them to be planted earlier in the season, and hence get a jump start on some of the plants that they would otherwise have to compete with. Also, we're growing along the same lines as the pre-inoculation, I guess. We want to know if different shrubs benefit more from being cultivated in their own soils versus other soils. So the microbial communities in one soil more advantageous to growth than in another soil. So here we've got bitterbrush growing in cheatgrass soil. They're just starting to pop up their heads, which is nice. I was wondering if that was ever going to happen.
Wow.
So yeah,
those are
coming
huge.
Up quite nice.
Cotyledons, right? Or the...
Yeah. It's taken a long time.
How long ago did you plant these?
Oh, geez, it's been a couple of weeks. They're really taking a long time to kick in. And over here, there's some artemisia, and they're not coming up. The big sagebrush.
No big sagebrush yet.
Not yet, no. These are actually the awns of, let's see, this is Arista, 3 awns. And so these are some of the remnant plants that we found in cheatgrass dominated areas. So pick the seeds and you're growing them alongside of commercial varieties to see if these have better resistance to cheatgrass. This is just one of 4 or 5 different species that we found that seem to be holding on fairly well in cheatgrass stands. Those included Stipa comata, needle and threadgrass is its common name, basin wild rye. We'd really like to get some good competitive varieties of that for certain.
Do you have basin wild rye planted yet?
I do.
Great.
Hasn't come up, but nonetheless, they're here and growing. The greenhouse has very nice capacity. We're only starting to put a dent in the capacity right now. Within coming weeks, we should be able to fill the place up really well. Though this here is the Nemesis Brome Tech, or cheatgrass, and you can see it really dominates the area. These areas have been were sprayed last fall, and you can see.
Oh wow, it's working.
Yeah, they're taking a hit. They're not really that happy. You have to consider that this has only had a couple of days that have been conducive to growth at all, and this is one of them. And so they've been frozen all winter, but here they are dying, and I've been waiting all year to see if these guys would die or not. Doesn't look like there's a complete kill, but it's hard to say. Well, I'm standing in a knapweed patch in one of our riparian areas, which I think we can eliminate without the use of herbicides. And I think we can learn some lessons from studies in the Swan, as well as our trip to the Teller. Up there, deer were halting wordy species recruitment, and similar things were happening down at the Teller, except down there, exclusion of deer actually facilitated knapweed establishment. And I think what the difference between the Swan and the Teller is that we had long-term grass establishment there, as opposed to the Swan, which had been recently clear-cut. We don't have the thick grass cover. There's thick grass at the Teller, and so for knapweed to get any light at all, it would have to grow up above the grass canopy. And once it grew up that far, deer would come in and take it out. So inside the exclosures, it was free to grow up above the grass canopy. Here, what I think is going on is that the deer are not, they're taking out any woodies that come in. So I think the idea to getting rid of the knapweed in these areas is a combination of smothering the knapweed. For this, I'm proposing the use of wood chips or sawdust, and then deer exclusion. So a combination of actually 4 different treatments: planting, mulching, and exposure, and doing nothing. I want to do that here and another almost identical patch of the way.